Now I will introduce the GenIA end-to-end test platform. In the initial menu, we have the input type, which can be either free format or structured format. This input can be a user story or a test case. The user can upload a file or manually enter the information. In this example, I inserted a test case by providing the URL, the test case name, and the steps that should be executed. In the Projects section, we create a project, select it, and link our test case to it. We also define the name of the test case. Next, we select the framework, the output language, and other desired configurations. In this example, I will use Robot Framework with Python. After that, we configure the global parameters of the LLM. To do this, we access the sidebar, click on Config, and configure the required information such as the LLM name, provider, model, API key, and temperature. It is also possible to configure different LLMs for different purposes. For example, we can define specific models for particular projects, or even for specific stages of the pipeline. This flexibility is entirely controlled by the user. In this example, I am using different models with different temperature configurations. Here I select a global LLM. Once selected, it will be applied across the entire pipeline. In addition, it is also possible to select a specific LLM for individual stages and customize the prompt associated with each stage. To start the pipeline, we click on Generate Test. After that, the bottom panel appears. In this panel, we have the system logs and the pipeline stages. During the structuring stage, the natural language test case is transformed into a structured format represented as JSON. We can also visualize this process flow through the graph displayed on the left side. During the extraction stage, this structured JSON is processed and enriched through a web scraping step, which identifies the HTML elements required to execute the end-to-end test. In addition, users can copy the generated JSON or download the file. During the refinement stage, we aim to reduce errors and improve the quality of the extracted HTML elements. During the generation stage, the test script is created based on the framework and language selected by the user. In the validation stage, we identify the variables present in the generated script. In this example, the email and password variables were detected. Users can modify these values to automatically update the generated test script. There are options to continue without changes or apply the modifications made. In this case, we modified the variables. Returning briefly to the generation stage, we can see that the script originally contains the password variable. Since this variable was modified during the validation stage, the updated value will later be reflected in the script. In the confirmation stage, we can visualize the script before and after the applied changes. The updated version is then executed during the execution stage, where we receive the execution results. In this example, we can see that the script was executed successfully. Since we are using Robot Framework, additional execution evidence can also be generated. If the test fails, this evidence becomes available to the user. Additionally, the system provides detailed information about the specific stage or screen where the failure occurred. During the homologation stage, the goal is to generate a complete execution report. This report allows us to verify whether the test passed, whether any failures occurred, identify the cause of a problem, and obtain an overview of everything that happened during execution. During the finalization stage, we generate a report that considers not only the execution logs, but also the entire pipeline, including system logs, duration, and other relevant information. During the refactoring stage, improvements are suggested for the generated script. Since our script executed successfully, these improvements aim to further optimize code quality. If the test fails, the goal is to allow users to review the suggested improvements and execute the refactored version again. Finally, we click on Finish Execution. After completion, we can view different execution-related information, as well as filters that support future analysis, such as project filters, selected models, and other relevant configurations. This concludes an overview of how the GenIA end-to-end test platform works.